Okay, so we've started. Did you guys get that example where it was f of x over 1 over x? That linearization one? Linearization isn't hard. It's just you just have to remember the formula. That's all there is to it. So this was when you guys did in class. So that's all they gave you. F of x is 1 over x. Original x initial is 0.5. X changes by 0.1. So what you do is you take the derivative. That's 1 over x squared. Negative 1 over x squared. Everyone good with that? Because on your exams you will do a lot of derivatives with negative exponents. Do you guys want me to review this one? No? Okay. We're going to keep going. Okay. Because this is just x to the negative 1, and then you follow the rule. So f prime at xo is equal to negative 1 over 0.5 squared. That's equal to negative 4. So right here, we found f prime of x and f prime at xo. Then we need to remember that the change in f, basically you need to memorize the formula. It's f of xo plus change in x minus f of xo. So this shows you your error, something like that, or no, it gives you the linearization value. That's one of them.
Would we ever be given this in like a word problem?
They'll give you word problems with related rates, and you use like, yeah, those will all be word problems. But for this, they'll sort of just give you this stuff, and you need to remember this formula.
Okay.
And then it's just plug and chug. So it's not hard, but a lot of students don't realize they need to memorize it, or they forget to memorize it because there's so much to this unit. So this is equal to f of 0.5 plus 0.1 minus f of 0.5. All right. This I have 1 over 6/10 minus 1 over 1/2, which in the end is equal to negative 1/3. You did this in class. Let me just say that. So the main part was knowing this formula. That gives us the change in f. Now we also need to know what a df is. df is f prime of xo times dx. Okay? We found f prime of xo originally. That's negative 4. So we just multiply dx with it. Okay? And we know dx, that's change in x. So it's negative 4 times 0.1. So we get negative 0.4 or negative 2/5. Are we all clear on that?
Whatever the delta x is, that's what we'll always plug in for dx.
Yeah. And this you also need to know. And then to find the error, is equal to tangent f minus df, which is equal to negative 1/3 minus negative 2/5. This is equal to 1/15. So this formula you also need to have memorized. All right? Yeah. They'll probably ask you to find f of x with xo, that sort of a thing separately. And then for a part of the question, you'll need to remember the formula and get an answer. And then they'll say find df, and you'll need to remember the formula and find that sort of a thing.
So on a test, would they just like, would they be like question number 10, they would ask us to find all of this, or would it be like A, find f of x, B, find f of x0?
For us,
They like guide us through it.
For us, it was find f of x and then f prime of xo, that sort of a thing. So I'm pretty sure that's how they're going to do it again. And then you'll see more of those examples when we actually review this next week. Like, you'll see how they want you to ask questions, or how they're going to ask questions. So that's that. And then that tells us the error of us just doing change in f to find the tangent slope. This is the error of it. And then I'll just go through some formulas. So the linearization L of x is equal to, I think they said this is just going to be on the video, right? L of x. Yeah, so that's f of a minus f prime of a times, yeah. So this is L of x. They'll just ask you to find L of x. Yeah, and you'll have a function. They'll give you an a value, and then you find it. What L of x does is it allows us to find a function L of x that resembles closely to f of x. So it has certain error value, but it's an approximation. So memorize this. What you can easily do is write all of these on a flashcard. Just look over them. And Newton's method, they're going to test you on this too. And a lot of people just forgot to look over this. X of n minus f of x of n over f prime of x of n. This is once again a formula that you guys just need to know.
Like, use Newton's method.
Yeah.
X of n equals this, f of x is this.
Yeah.
Those are both things, that's all it is.
So they'll tell you to find x of 1, x of 2 when you are given x of o. Okay? So if we are given x of o, that's like x of n. So x of 1 would be n plus 1. If they ask you to find x of 2, you use x of 1 in here to find x of 2. Does that make sense? Yeah?
They don't say x of n equals, they say find x of 2, and we know that that is one
Yeah.
higher than what we need to use.
Yeah, yeah. So they might ask you find x of 2, and they give you x of o, so you need to do it twice. So this is on the video, so just I'm pretty sure it is. Once again, df. Know all of those. Did they cover absolute change with you guys? So for absolute change, it's that formula, okay, which is also, so those involve these two formulas. That's with absolute change, okay? And this is, I'm pretty sure, just going to be on the video, so you really have to watch them. And then relative change, and I may be just going ahead into the material. Relative change is change of f over f of xo, or that's the same thing as df over f of xo. Okay? So just remember, change in f over f of xo. If they ask you to find the relative change, that's the formula you use. That says df over
Wait,
xo.
so what's the difference between?
It's just f of x or df. They're the same.
Oh, so df and dx are just the change.
F. To find the percent change, you multiply that by 100. Okay? So on the test, since this is an objective, they'll test you on this, but in class they don't cover these topics, or they briefly mention them. So you do need to know how to get percent change, the formula for relative change, and for absolute change. It's what we did up here. So now let's do the related rates problem they did in class. Are we good with this? Yeah. So the main thing to get out of this is not a tough topic. It's just you need to sit down and memorize it. And students just forget to do that and they lose the points.
So what you're raising now, what was the question? Find what? Find the error?
They had you find change in f, df, and then you use those to get error.
It'll tell you, okay.
So change in f and df are not the same things, okay? We got two different values from them. But when we subtract them, we find the error with it. Okay?
No, I don't know everything I made.
So in the relative change, you do need to know both. So right here, I would write down both.
So they would ask, what's the
Relative,
relative,
yeah, with change in f or with df.
and we would have to probably find the change that.
Yep.
Yeah.
Is dx the same as change in x, or is it also different?
No, the dx is changing.
It is
Yeah,
always forever.
Yeah.
Wait,
Dx is equal to
dx and delta.
change in delta x.
And f is not.
So what was the formula for linearization? I just phrased it.
F of A minus F of A times F of X minus A.
Yep.
So what is the difference between the change in F and df?
That's in that little proof they showed you with the graph and stuff. Let's go back to that.
Isn't DF like R predicted change pretty much? It's like what we predict the changes.
Sort of. Yeah. Let's see the graph. So this is what they have on there. If you have a curve with 2 points and we do the tangent line with it, from here to here on a point on a curve, this is change in x. From here to that point on that curve, this entire thing is df. Okay? And this little gap is our error. So if we use approximation with change in f, we'll have a certain amount of error, like in those ways or something. Or with df. Let me go to a different graph. Yeah, so df is what we use to approximate with, and that's change in L, right? But that has certain amount of error, and we need to find change in F to find that error. I hope that made sense. That's how it.
So when you're using DF, it's basically implying that you're using
Yeah. And there's a certain amount of error. Any other questions with that? So let's cover some related breaks problems. These can get pretty tough. So the first one that they do is just looking at a circle. Area of a circle is pi r squared. A is in terms of r, so this can be written as A of r. Okay? So if we take the derivative of A with respect to time, because related rates are concerned with most of the time the examples involve water flowing, so the amount of time it takes for water to flow out of a hole or something. So that's why we have to do one with respect to time, but A is a function of r. So we can take the derivative of A with dr, but according to the chain rule, then we have to do dr over dt. Take the derivative of r with respect to time. So then in the end, we end up with dA over dt. Right? So this is equal to taking the derivative of A, since it's with respect to r, we get 2 pi r. But then we need to do r with t, so that's times dr dt or r prime. We'll just do dr dt. So this would be your little answer for this. And they could give you dr dt, the rate at which the radius is changing. They could give you a function. They could say r is changing with t squared. So you do the derivative of this. Yeah? Did that make sense to everyone? So the example that they did was with volume of a cylinder, which is pi r squared h. Volume is a function of r and h. Okay? Because it has two variables in it. But if we want to know the relative change of volume, we need to take the derivative of it with respect to time. So then we get pi, and then it's the product rule. We take the derivative of r or we can do H or R first, whichever. We'll just do H. So we get R squared dH dt plus H, and the derivative of R is 2R dr dt. You guys see how that worked out?
Is there something like how you wrote dn or dr, you were accumulated or something?
Yeah.
Same
So it'd be
thing like that.
the same thing for R. We do dV over dr times dr over dt. We were taking the derivative of the volume formula with respect to R. Okay? This entire thing, we're not looking at pi because we already took that up. So for H, let's just look at that. Okay? If we're taking a derivative of this, imagining that R squared is like a constant, okay? The derivative of the volume with respect to H is just 1. So if we do dV over dH times dH over dt, this would be 1 times dH dt to make it a derivative of time. And then we still leave R squared because we treat it like that as a constant. Okay? Then we do the product rule, which is looking at the other term. We treat H like a constant. We take the derivative of the second number. Okay? So you guys remember that? So then it's dV over dr, which is 2R times dr dt. I'll say that again.
So whichever one you're taking the derivative of is the one that you do the d blank over d.
You guys don't really need to, for this unit, understand this, but it's good to like know the background why it happens. V is a function of R and H, okay? It's not a function of T. It's not V of T. So when we take the derivative, we can take the derivative with respect to R and H, right? But then we still want D over dt because time flows, so like the change occurs over expansion of time. So we treat this as like a product rule where we take the derivative of the first plus, like that. So here we took the derivative with respect to H. We have R squared, which we don't take the derivative of. The derivative of H is 1, but that's dV with dH. We still need to multiply it by dH dt. It's like implied differentiation. Yeah, implicit differentiation. Since we're doing the derivative with respect to x, we need to multiply by y prime. This is the same thing as h prime, and this is r prime.
So what is dV dt? Well, is it just going to be a formula for this?
dV dt tells us the change in volume with respect to time.
Okay.
So then you use that idea to calculate how long something takes, or like that. And I'm going to get to that. So do we understand what happened here? So you just treat each variable like, you do y with y prime. Do you have any other questions? Related rates. Yeah. Okay. So next problem you did in class is what's volume using that formula. So they told us find the rate of change of volume. That's dV over dt. Okay. When R is equal to 20 milli, or 20 meters. Height's equal to 10 meters. R is increasing at 0.5 centimeters per second, and H is increasing at 1 centimeter per second. Okay? So the first thing they did was just convert these to meters per second, all right, which is changing centimeters. So this is equal to 0.05. Did I write them right? Oh, R is increasing at 0.5. I think I wrote them wrong on here. Well, so D, let's remember, dr dt. Oh, I gave you guys the wrong values.
I think that's right. Although I think H,
No, dr dt.
uh,
The rate at which R is changing is 0.5 centimeters per second. dh dt, the rate at which that is changing, is decreasing at 1 centimeter per second.
would that be negative?
Yeah, we can put a negative there, yeah, or we can make it a negative in the problem. Looking up there, we found what the formula is, dv over dt. Once you find that formula, it's much like plug and chug. We do pi times r squared. They told us r is 20 meters, so that's 20 squared times at which r is changing. No, sorry, dh dt. H is changing with negative, and then if we do meters negative, that's negative 0.01. Right? This is h prime. This is r squared plus height is 10. 2 times r, 2 times 20 times dr dt, which is 0.005. So this is r prime. So we just plugged in chug, basically. We just needed to remember that this needed to be in meters while we were doing centimeters. So dv over dt is equal to pi times -4 plus 2 -2 pi. And then our units are meters cubed per second. You did this in class as well. For volume. I mean, yeah, you should know that everything should work out like that. So volume is meters cubed, and it's with respect to time, so it's per second. So if we look at our units, we have r squared here, that's meters squared, times the rate of height, so that's meters per second. Here we have r, which is meters, height, which is meters again, and the rate at which r is changing, meters per second. They all multiply up to be meters cubed per second. So if you look at the units and you did something wrong, they don't add up to meters cubed per second, you probably messed up somewhere in the formula. I think that's as far as they got in class, right?
So is this the same section as, like tied in with the stuff that we had before break, like with the tree, identities and stuff?
No, this is the new section. There aren't trig identities in Unit 7. Wait, there may be.
No,
Yes,
that's,
do that.
I think that was part of the,
Yeah.
we,
but that's just knowing what the derivatives are.
But this is for like the next, like not the upcoming test.
Yeah, this is for your test on Thursday.
Or upcoming test.
No, your first test is on Tuesday.
Oh, yeah, this is the second test.
Yeah. Yep, you guys have to do that.
Could you do one of the, like?
Yeah.
later,
Like what? Linearization? Linearization ones? Like the trig ones? Okay. I don't have the homework with me. Sure.
how was your break, Daniel?
That was good.
That's good. Did you sleep?
Yeah.
Did you have a 3-day or did you study?
I studied.
Oh.
So you guys all understand what they did in class with the chain rule, right?
Yes.
Oh, yeah.
So just any questions on this?
What?
Any questions on this?
I have to do like
Yeah.
mental decimal math. It's like,
I
I don't know how to do it.
I didn't write it down there, but you can work it all out on paper.
Yeah.
I just didn't do it because they did it in class. But make sure you understand, it's like taking implied differentiation or implicit. Okay. Yeah, you can say. Oh yeah, those. Thank you.
Oh, yeah.
Tangent 6 theta over all over theta squared of tangent 9 theta.
Okay.
That's your breath sucks.
We should start working it out.
You have to remember, you can't have theta in the denominator. Okay. Or you have to find a way to break it up. Yeah. So what do you guys think is the first step?
We did break tangent into sine 6 theta.
Yep.
Sine 6 theta and the same with cotangent.
Yep. So you have a tangent theta, right? One of our identities they told us is sine theta over theta. The limit of that goes to what?
1.
1. So we need to find a way to incorporate that into the problem. So we see a tangent, so we can just do sine of 6 theta times or all over cosine of 6 theta. Okay? That's what that tells us. And then we have cotangent of 9 theta, right? What does that tell us if we break it?
Cosine.
Yep. Or what? I'll take. I'll make them 1. Okay? And then we still have over theta squared. Alright?
So you change it to multiply.
I mean,
Well, it's
this is,
You're just
oh wait,
dividing by
sorry.
cosine over.
Sine would be on top, right?
It's not really on top.
Yeah, sine would be on
Oh,
Yeah.
see.
top. Yeah, good. What do you guys think we should do next?
Split it up. Split it up. No.
You can,
That's a little easier.
but what would you multiply by?
So like, I would make the limit sine 6 theta over one of the thetas, and then I could multiply that times like 6, and, and then I would handle the next sine 9 theta over theta, multiply that time, and then I would do, you know what I'm saying? And then I would try and get the cosine theta to be like, is it
So basically, let me open that.
I will put one, it'll work out okay.
Oh,
It'll
oh, like
work
the
out.
identity.
Yeah.
Yeah,
Yeah.
use the
They did
identity.
it a harder way,
IDK would use it.
but anyway. Break it up.
Yeah.
Break it up. And
Yep, 1 second. I'm opening up. I haven't gone to real life yet.
No, 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 in this.
You use it a lot in Calc 2 and 3. Okay.
they would die.
Wait, are you in Cal 3?
No, I'm in differentials, which is like Calc 4.
The real shit, man.
Okay, so you said to break it up, right?
Yes.
We can do that. So limit as theta approaches 0.
9, 6, 8 over 3.
Do you see what we're doing?
Yeah.
I did.
Times. And if we want to write it all down, we'll just do limit as theta approaches 0 of sine of 9 theta over theta times limit as theta approaches 0 of 1 over cosine of 6 theta cosine of 9 theta. Technically, you didn't need to rewrite multiplication of those. You could just put parentheses and the whole thing will be under 1, right? But the next idea is that we want this to be a 6 in the denominator, so we can multiply that by 6 over 6. Okay?
Is it okay to, does it work out the same if I multiply like the top by 9 and the bottom by 9, like the numerator? So I have 9 sine 9 theta over 9 theta.
Isn't that what I'm doing right here?
I guess.
Because by this I mean multiply the whole, like,
Oh.
yeah. I just wrote it to like all of it. Okay? You guys see that? So then that's, and then we need to say as 6 theta approaches 0, as theta approaches 0, 6 theta approaches 0, and 9 theta approaches 0. You need that. As theta approaches 0, 6 theta approaches 0, and 9 theta approaches 0.
That's something I like to look for.
Yeah.
Right answer.
Because the proof that we did was for theta, sine of theta over theta. We need to show that it's the same whether we multiply by 6 or 9. Right?
Where does that need to be? Can it just be anywhere?
It can be just on the left like that.
Just put it in there, they'll find it.
Yeah, so it's limit of 6 theta as that approaches 0. 6 sine of 6 theta all over 6 theta. Right? 6 on top, 6 on bottom. Times, and I'll just do it over in one bracket. 9 sine of 9 theta all over 9 theta times 1 over cosine of 6 theta times. Actually, no, we need separate brackets. We need to show like this, so it'd be the limit as 9 theta approaches 0 of 9 sine of 9 theta over 9 theta. We need separate ones, okay? Because one has 6 theta, one has 9 theta, and this one still just says as theta approaches 0, 1 over cosine of 6 theta cosine of 9 theta.
We don't need to write, we don't need to like separate it and make, even for the cosine, we don't need to make it 6.
No, I mean, yeah, it's the same. So this tells us that this approaches 1. So we can do for this little part, not the 6. This little part approaches 1. Okay? So then we can just make this equal to 6 times 1, 9 times 1, times 1 over that. 1 times 1. which is 54. I mean, you don't even need to show all this. You can just show a 6 here and a 9 here. Show these are 1s and have it equal. No, actually, I would go ahead and show this.
Doesn't have to be that.
Yeah, but they might want you to see that they might want to see that you plugged in everything without showing the limit sign.
You recognize the sign.
Yeah. So did that make sense? So the whole idea with these problems is that you need to think of ways to get sine theta over theta. And then you just have to think during the test. There is no just one method to doing this. Sometimes you have to break them up. Sometimes you have to multiply on, like on the problems they did 5 theta over 4 theta, all over 5 theta over 4 theta. Like that was example problem. We can go over that. So there's just, you just need different ways to do it. And the best thing you can do is just do problems.
There was a homework question that said use the half angle theorem and then just add the I looked into objectives and I wouldn't want to use objectives and like I Googled it and I found it, but like you can memorize the half angle theorem and the double angle theorem and stuff. Like,
Is that with like sine squared theta is equal to 1 plus cosine 2 theta over 2? Or sorry, minus. Yeah? You need to know this. That becomes really important later on. That one is, so for cosine squared theta, that's 1 plus cosine of 2 theta over 2, right? So what's for sine squared theta?
the whole thing of
It's 1 minus
Right? So the only difference is the plus and minus sign. With sine, we have to subtract. Those you do need to know because they're helpful. What do you mean?
so then the half angle is on the double. That both with them.
You should just know that.
Just know those.
Yeah. I mean, they give you that list with stuff that you need to have memorized. So if you know all those, you're good.
We won't have to prove any of those trig identities.
You will have to derive some trig identities. Because that was an objective.
They had like 3, right when we started talking about verse 3, she had like 2 like these are 3 that would have to prove.
Yeah.
She said we don't need to prove anything else, but these 3 are going to be 3 of them.
Who said that?
Yeah. it's-
This one is sine of 5 theta over sine of 4 theta. Okay? They did this in one class, so it's the limit of theta approaches 0. For this, we can't just multiply by one number, right? We need something with 5 theta and 4 theta. So then we do 5 theta over 4 theta all over 5 theta over 4 theta. Okay? Did I do that right? Yeah. Let's limit as, so then we need to show as theta approaches 0, 5 theta approaches 0, and 4 theta approaches 0. Okay? So then we can just do as 5 theta approaches 0, sine of 5 theta over 5 theta. We show that. Then we still have limit as theta approaches 0. All of that in a second. In the denominator, we have limit as 4 theta approaches 0. We have sine of 4 theta over 4 theta. On the top, we're still left with 5 theta over 4 theta. This 5 theta is divided with that. This becomes the denominator.
We have like fractions
Okay.
inside the fractions, so if you like
Sorry,
a
not
fraction,
this one.
fraction on the bottom, is it like the top, goes
This
to
one.
the top, and the bottom, and the bottom? You understand?
Yeah.
You have like a fraction of numerator, fraction of denominator, you take the tops.
So this is what you're saying. It's like if you have 1/2 divided by 1/6. Yeah. So like if you have 1/2 divided by 1/6, that's 1/2 times 6/1. That's basically, this one is the denominator, this is the denominator of that. We're left with 5/4 theta, or 5 theta over 4 theta. This is a 1. This is a 1 as well. The whole thing. She wrote an extra step, but we don't need that. We can just do it. So this whole goes to 1, or we can just show that they cancel out. And we get 5/6. You can even do 1/1. Right? So this is the one Tyler was talking about, where he said a student was like 5 times sine theta over 4 times sine theta.
This is the one that he said that he took off more points.
Yeah. Yeah. Like someone did 5 times sine theta or 4 times sine theta. They did that. In many states. In Kentucky, it's legal. This
Can you do one with the continuous expansion? Because I'm going to do that. It says find f ext of 0, the continuous extension of f of x equals sine squared x over x squared.
Can you bring it up here? I'm not sure. We're done with this one, right? Yeah. So next week, my session will still be at 3. I will not be able to do a night session. So on your test before Thursday, it will be this time. At 3.
So Monday, at 3 here.
No, Monday will be at night. Wednesday will still be at 3. Okay. Do they do something like that in class?
If I did, I missed.
Oh, this, what was it? Sine of what?
Sine squared x over x squared.
Okay.
X equals 0.
Okay. So this is kind of the same thing. It's saying if we have a limit as x approaches 0 of sine squared of x all over x squared. Okay. What do you guys think we should do first?
Maybe like sine of x over x times sine of x over x.
Yeah, yeah. Break it apart. The limit as x approaches 0, sine of x. Okay. Right?
So it's just 1.
Yeah.
That's a problem when you get.
But the tough part was it was worded differently and it had x's. Okay? So it was you have to find the extension of f at f of 0, which if we just plug in 0 here, that's not possible. But if we do the limit of it, we can find that.
What is the continuous extension?
I think it means if there's a hole, you won't get a value, but if you take the limit of it, then you can get a value if it is continuous.
Oh.
I mean, I don't think there's much to it.
Extension, that's what it says.
Yeah.
Yeah, like if you
There's a
put
hole,
limit
but
exists, it's undefined at the point, then make it equal to the.
No.
any other questions like this? So that was the last unit. So on the next exam, what units will they cover?
6 and 5.
And
So-
or three.
Yeah.
6 in the breath.
But don't forget unit 5 as well.
So like all of the three.
Yeah.
Are
All
you
of,
dropping hints right now?
oh,
Yeah.
it's, I mean, like since the exams are, you've had a full week in between without exams, and the fall break, people
Yes, yeah.
forget to review those material, but this test includes units, proofs as well. So, as I mentioned before, proofs of sums, proof of the power rule proof.
Look at more than one proof on this exam.
Will they what?
Put more than one proof. Who wants to get more than one?
They'll probably just do one, like the power rule portion, one of those objectives. So this is probably, they can do whatever on the test, because it's all objectives. They can test any objective, right? So they can do product and quotient rule, test them both. But in the past, they've done one. They might do the power rule this time, so definitely look over that. What did you guys have the last time?
Wait,
What?
John, what was it again? It's like they gave, whatever the opposite of it, whatever they gave.
Yeah. So they'll probably do the power rule, and then
Yeah.
We should have.
I think
We did it, you're right.
did you guys derive stuff in this unit 6? You derived stuff in unit 6, yeah.
I have a question.
Yeah.
Okay.
Okay.
Like a homework, and it was like S equals, this is like a velocity acceleration curve. It's like S equals A cosine 2 pi dt. And once you like find the formula for velocity acceleration in Earth.
Yeah.
And I just got confused because it started like, I would always get like the cosine becomes sine, or like negative sine.
Yeah.
Like, then on the outside, it would be like pi squared b squared, or like pi cubed b cubed. And like,
Yeah. You just make sure you write them.
I was confused with how they did that.
All right.
So, so you had like, I'm just gonna make this up. Say cosine of pi t, right?
Okay.
What's the derivative of this?
Negative
nine, five, and then the derivative of five.
yeah.
So negative
Yeah.
negative pi times sine
Is it
of pi t, right? That's the derivative of f prime, right?
Oh, and it's pi because that's what.
It's the derivative of the inside. Now, if you were to do the second derivative, what would we get? Negative pi squared cosine of pi t.
Well, so you have the negative pi, so that's going to be times.
Derivative of sine is cosine of pi t.
Oh, and then
Pi.
it's-
Of the inside, we take out a pi, so it's negative pi squared.
Okay, good enough.
If I had, so.
Triple.
A never. A was never.
So what is the third derivative of that?
Pi cubed.
Sine.
Yeah, sine.
Of pi t. The derivative of negative cosine is sine. We take out a pi, so it's pi cubed. Like you don't really need to know the derivative of negative cosine. The derivative of cosine is sine, negative sine. So it's negative, negative, so it's positive. Did that make sense? Make sure you guys really review chapter 6 with all its trig identities. So on slide 36, or my 36 on my slide, it says deduce these from trig identities. It's like tangent squared plus 1 equals secant squared, 1 plus cotangent squared equals cosecant squared, sine of 2 theta equals 2 sine of theta cosine of theta, cosine of 2 theta is cosine squared theta minus sine squared theta.
Are those all derived from like cosine squared?
Like sine of a plus b,
Oh.
like cosine of a plus b. Yeah.
That's why I went back and looked at you. I asked those four, and then the very first one, the one so she said.
Well, the first couple of them, like, what's actual trig?
Yeah, you need to know how to prove them because everything else.
Yeah, there's 2 slides with identities that you can, more than 2 slides. Yeah, but then there's, no. Yeah, so there's 3 slides on there full of trig identities that you guys need to know how to deduce. Yeah, and you also definitely need to know how to get derivative of sine is cosine. You need to prove that. And then don't forget law of cosines. What's law of cosines?
C squared equals
Yep. What's law of sines?
Well, they gave us a question on that. Would you like the homework one that we had? Because I found that one really weird. How they gave us 2 angles as radians and wanted us to find
Third angle.
the other one is find the side.
Yeah.
Opposite of the angles.
So did they give you another side?
They gave us one side, 2 angles.
Yeah.
None of them matched up. I thought we were like, I figured out how to do it, but I didn't understand why.
So you guys all know the unit circle? Okay. That was in the last Wednesday one. So they say this is, we'll just call it pi over 2. We'll call this pi over 6. Okay? If this is 3, 4. Alright? Log, so we have to find this side. Sine of pi over 2 all over, we'll just call it A. Sine of pi over 6 all over 3. What's sine of pi over A? 2? No, like what is the sine of pi over 2? 1. So we have 1 over A. What's sine of pi over 6? It is 1/2. Divided by 3. Therefore, A is equal to 6. Yeah. Right? Do you guys see how that happened?
Could you possibly do one where you like my homework example was it gave me side C, which was 2, and it gave me angles A and B. And
So yeah, I mean, that's the same thing as me not giving you guys 4.
also have a 3. is what I'm saying.
Yeah,
You know 3, but you don't know.
so I'm not giving
Maybe that's
anything
what-
opposite. I'm not giving any of it.
Oh, okay.
So like where your zeros at is
What about log?
in between pi 2 and pi 6.
Wait, we have to shoot on anything?
Yeah, if it gave me 2 angles, and it gave me a side.
Yeah.
All right. We gave you 2 angles.
And like I figured out how to do it, but I don't understand why.
Okay. What shape is this? What do all the angles add up to? So we can find this, right? Now, if you're given radians, what is 180 in radians? Pi. Pi is equal to pi over 2 plus pi over 6 plus, we'll just call it x. We'll call it x. We could call it theta or whatever, right? X is equal to pi minus pi over 2 minus pi over 6. So this is pi over 2 minus pi over 6, which is 2/3 pi. No, 5 over 6 pi.
Wait, where did you, where did
2/3? Yeah, it's pi over 3 actually. What?
where did I go?
Pi minus,
Oh, it's, okay, yeah, that makes sense.
because it's a triangle, they have to add up to 180, which is pi in radians mode. So if I give you actual values, so this is a 90, this is a 30, we know this has to be a 60, which it turns out to be a 60. And then if they gave you 2 sides and 1 angle, you can just use the law of cosines. But that angle has to be between them. Like, they have to give you those 3 for the law of cosines to work. Yeah. Let me go look at that. Yeah. So if this were a law of cosines, theta would need to be between A and B. Just remember that. Okay? Like, you needed this angle. They can't give you this angle and without this angle, and then you have to do law of cosines. That's not how it works.
So if we're given 2 angles and a side, and the chances are that's going to be a false sign. It's the other way around.
Yeah. So, yeah. But with law of cosines, it's the biggest angle. So in this one, it wouldn't actually work because this is a 90 degrees right triangle. You need an obtuse triangle. Are we good with that?
Yeah.
And then in unit 7, you go into this whole deal of max and mins, which is what awaits you guys Friday.
Is that hard?
Your answer is like,
It might be hard.
I don't think it's hard. I think
No.
it's super exaggerated. I feel like all the steps that you have to do. Well, we did in high school. It's like, I just wanted to shoot myself in the face.
It's just, again, it's understanding all the steps that you need to take and then just doing all of them. Like, you have to test each endpoint. You have to find the derivative. You have to find where it's undefined. You have to find where the endpoints with that. and then you test those points, see whether they're max or mins. So it's a lot of just simple calculation. But what? That's unit 7. So that's Thursday.
Tuesday. What? You know what Thursday does? It's not Thursday.
All our tests for me were on Thursdays. Yeah.
We have this Tuesday is 6 and then Tuesday after that is 7.
Oh, what?
No, she's just.
What? No, I'm right. Am I not?
So that we got T tests next week.
Yeah.
Wait, for real?
Wait, you guys didn't know that?
This whole day
what I was
freaking
told
me
this
out, bro.
Yeah,
You Josh it.
So just to clarify, you guys have a test next Tuesday and next Thursday.
We got this.
So unit 6 Tuesday.
Unit 7 Thursday.
Wait, so when are they gonna have our next test? On Thursday? Are we having a Thursday test now? Is that a thing?
No, just to cover up for this week.
Next week,
What
next
are
week.
you talking about, Liz? What are you talking about, Liz? This says exam 7, Tuesday, October 13th.
It's on Thursday.
Why would they put it wrong on the
I
schedule?
think Tuesday, October 13th.
Doesn't include unit 6, and then
13 is Tuesday. 15.
that's not the schedule. They're not supposed to deviate from the schedule. This is.
Are you sure the schedule says that? But no. Just remember, you guys have 2 tests next week, one on Tuesday and one on Thursday. Like, I'm sure you guys do. Ralston
Why
confirmed
would
it.
she say that? That's so mean. They lie on the schedule.
Let's go to, maybe they updated on Blackboard.
No.
This isn't okay.
Wait, you guys didn't know this?
No.
Because the schedule doesn't say that. I'm standing up.
I didn't know until you said it earlier. I guess I'm so very excited.
Yeah, that's what I was saying. On Wednesday will be the SI session prepping for the test on Thursday.
1000% sure.
Yeah.
Oh my god.
But look.
Oh my god.
But they're
Right.
but no.
On that schedule,
This is such a problem.
on 13, it says exam 6 on Tuesday. Wait,
It says it. It says Tuesday for both. I do.
it does say it, but trust me, it's not that way.
Wait, how do you know?
Like, why would?
Because they told me.
But they didn't tell us.
Why didn't they tell
Why?
us?
We're more important.
I thought they did tell you guys.
No. Wait, so is our homework due on Wednesday then?
You have to look on my math lab.
Oh, and then if the homework is due Monday, then.
Yeah, you can check it by
Oh,
that.
Because on my math, I'm pretty sure it says it's next Monday for unit 7. Homework.
It's June 19th, which is Monday. Oh,
So,
This one?
I will
what's the truth?
I will tell Ralston to email this out. Or I'll email her letting that you guys are confused.
They can't do that.
All right. That's the end of the session.